Hey folks. Okay, in this one I want to talk about homoiconic languages. So these are languages that can essentially read their own source code as valid data structures in the language. So the code that you actually write in matches the data types that the language expects to work with. So we're going to use this to create some self-parsing code where a program written in the language can look at its own code and figure out what that code represents in a reasonable fashion. So there are a ton of different homoiconic languages out there, Scheme and Racket and Lisp and Clojure and a whole slew of others. Of course, what we're looking at for now is Lisp, so we'll play with that for the next little while. So what we're going to do is look at parsing Lisp programs in a Lisp program. So we're going to build a little tiny translator or descriptor that can take a list of Lisp statements and then build a description of what those statements are. So if you give it a list that's got a function call and a number and a list, then this translator will actually come back and say, oh, you gave me a function call, a list, or a function call, a number, and a list, or I can't remember what order I said those in. But this is the idea. So what we'll have is a top-level function that we'll call interpreter that just makes sure that we actually gave it a list of statements, and then goes through the list one statement at a time and translates them one statement at a time. So we're going to have a second function called interpret1 that just takes one single statement and interprets that, and then adds the description string for that to our list. So this is the idea: top-level one to handle the list, and then a little internal one to handle one statement at a time. So what we're going to do is just build this up incrementally. So we'll just start with something that only recognizes a couple of types of statements, and then gradually we'll add more, and we'll leave it kind of open at the end so you can continue adding more and more and more if you wish. So our top level one is pretty straightforward, right? Our interpreter as a whole is really just looking at taking a list and calling interpret1 on it. So it's getting a list of statements. It's making sure that, there's a T missing there. It's making sure that, so this should be a list P, making sure that the statements are actually a list. Going through and saying if the list is empty, we're done, right? There's no statements to process. Otherwise, what we'll do is call interpret1 to get the result of the front statement, and we'll add that to the result of a recursive call where we go off and translate the rest of them. So this is just a pretty straightforward recursive processing of the list, and all of the real work is being done in interpret1. So let's take a look at that. So for interpret1, we want to take a single statement and generate some kind of description string for it. So a string that says, okay, this was an integer, this was a real number, this was a list, this was a function call. So what we'll do is use the type case function to look at the data type for the statement that we're given. You know, is it a function, is it a number, is it a list? And if it's a list, then we'll make a recursive call to go through and analyze the contents of that. So, and our description strings will be just really basic, just, function call, integer, string, list, something like that. And again, we can build this up to be more and more complex as we go along. So our interpret1 function, again, this is taking a single statement, and we're using type case and say, okay, well, what kind of thing is that? And if it comes back and says, oh, that's a function, then we'll just return the string function call. If it's a number, we'll say it's a numeric value, etc., etc., etc. And if it's a list, we'll actually go through and see what it's a list of and build up a list of the results. So we'll build a list of the results. And so for our top level description, we'll say it's a list of, and then we'll produce this list of whatever it's a list of. So then we're going to go back. We're going to have a list of values we want to translate. Well, that's what our interpret function was meant to do. So we'll call interpret on that statement that we know is a list. Right? So that takes us back to our interpret a list of statements, which in turn is going to go back and process the statements in this by calling interpret1. So we get this kind of recursive relationship going on. And again, what we'll do is we'll have code to recognize whatever data types we're set up for so far, and then just anything else, we'll say it's something else. So again, as we go through this, we can just keep adding more and more kinds of things that we recognize. So if we try this out right now, and we run interpret on, let's say this is the list of statements, and we're just going to see what it does for us. Right, so this should come back, and after it goes through that cycle, right, it's going to recognize the first thing. It's a 25, that's a numeric value. Right, so it's generating this list as it translates one item at a time. Right, it recognizes that foo is a string. We haven't put anything in to recognize Boolean values yet, so it says that's something else. It sees the interpret 10 and recognizes that as a function call, or pardon me, recognizes that as a list whose contents are a function call and a numeric value. Right, so it gets this and says, we've got a list, so it says list of, and then it says what's in there is a function call and a numeric value. Now, again, that's fair enough, but really, I would rather have it recognize this as actually being a function call that's saying it's a list of a function call. So what we could do is, if what we want is something more like this, where it says it's a function call, here's the name, and then whatever the parameter list happens to be, we can tweak this, and let's say if we see something that's a list, instead of automatically saying list of blah, what we'll do is call a separate function that goes through and is specifically designed to interpret lists. So let's go off and take a look at that one. So our interpret list, again, we'll throw some error checking in the beginning. If it's a null, we'll say it's an empty list. If it's not a list, we'll return nil. But then what we'll do is, if we know it's a non-empty list, we'll take a look at the thing in front and see if this is a function call. So if the thing in front is a function, then instead of just saying it's a list, we'll say it's a function call, we'll grab the thing in front as the name of the function, and then we'll do an interpret on all the rest to figure out what the parameters are. And if it's not a function call, then we'll treat it like a regular old list. Right? So we'll say it's a list of blah, blah, blah. Right? So we can start expanding and customizing how we handle the different pieces of the language. So now when we run it, so if we run it on that same thing, it's going to go through and say, okay, well, the first few elements are still the same. And when it hits that function call, it says, oh, it's okay, now it's a function call. And it's going to go through and try and interpret the rest of this beastie, right? It tells us what the name of the function was, and it tells us that the rest of the arguments were a list that contained a numeric value. That's because the way we set it up was to go through and analyze this kind of recursively. So when it was doing that, we pulled the interpret off the front as a car, and then the rest of this stuff was a cutter for all of the arguments. So it thinks the arguments are a list of arguments. So, maybe we want to go through and just have it say fun call interpret and then one argument at a time. So instead of going through and having our list fun call car and then interpret the cutter, what we'll do is say, okay, well, we've got the list that's the function call and the head, the name of the function, and we'll append the results of the recursive call instead of making a list of the elements. That way, the numeric value just comes out as the next thing in our list. Right? And again, you can continue on and just keep refining this more and more and more until you get the behavior that you want, and until you can process all of the different data types that you want to be able to process, all of the different language components that you want specific interpretation for. And again, anything that you haven't implemented so far is just going to appear as a something else. And again, you can get as fancy as you like with this, adding file handlers so you can read the data from files and whatever else it is you want to do. So we can make this as sophisticated as we like. Now, just before leaving off, we could go through and have it recognize specific keywords that are built into Lisp. Right? Instead of just saying let as a function call or cond as a function call or something like that, we could have it recognize that, oh, this is a let block, and have a custom thing to handle a let block. Or this is a cond, have a custom thing to handle a cond. And if you think about it, the read function that we have in Lisp reads whatever it is the user types in, and it recognizes what kind of thing that is, right? It recognizes it's a list, or it's a number, or it's a function call, or something along, or it's string, or whatever it might be. So that read function has to already be doing something very close to this. Well, probably a little bit more sophisticated, but the same kind of idea where it's going through and figuring out, what kind of thing is it that we're being given. All right, so the read function is actually a really powerful and really interesting piece of Lisp. But we'll leave that as an issue for another day. Again, hopefully you see the kind of the power of having a language that can read its own data as its own data types. All right, we will pick up more next time.